Let's learn how to graph reciprocal functions. We're going to graph the parent equation and then move it with transformations. These will have asymptotes, so we'll have to draw those on, and we'll plot 4 points. Let's get ready. You're going to need notes, pencil, and your calculator. And here's what we're going to be graphing, something like y equals 1 over x. So I'm asking what you notice. So we've been working on rational expressions, which have the variables in the bottom. So that's what happens here. We have 1 over x. So if I think about this for a minute in terms of 0, can I plug 0 in for x? So if I have 1 over 0, what happens there? That is a no-no. So we can't divide something by 0. So that's undefined. So we know that x cannot be 0. And that's going to signal to us on our graph that we're going to have an asymptote at x equals 0. Well, is there any way that y could be 0? So could I have y be 0? Is there something that x could be? No. So y is never going to be 0 either. There's nothing that you can plug in. So we're also going to have an asymptote at y equals 0. So these graphs are going to have 2 asymptotes. So let's come up with our table of values. We don't know what the shape is going to look like. We just said that it can't be 0. So I'm going to put 0 in the middle here. I'm going to plot 4 points because we're not really plotting this one. And we know that this is undefined. We just went over that. So that means when x is 0, I'm going to have a vertical asymptote. So VA for vertical asymptote, and it's at x equals 0. I also know that I'm not going to have any y equals 0. So that's my horizontal asymptote, and that's y equals 0. So once we start moving these things, we're also going to be moving our asymptotes as well. So with my vertical asymptote, x equals 0, I want to pick a couple numbers less than it and a couple numbers greater than it. So we're going to do -1 and -2, and then we'll do +1 and +2. We're going to plug it in. So I have 1 over -2, which is -1/2. So I'm going to go to -2, -1/2, and I have a point. And when I plug in -1, I get -1. So I have -1, -1. Now, unlike when we had the parabola and we could just think about moving our vertex, that was the easy point to see, this is one of the points that we're going to move when we use transformation. So the point -1, -1. If I were to keep plugging in values smaller than -2, so if I plugged in -3, I'm just going to keep getting smaller and smaller. I'm never going to reach 0. So we're approaching that asymptote. And then same thing, as I start to put fractions in getting closer to 0, it's going to approach my asymptote. So we have this one branch here that is curved. It should have double arrowheads. It should not be touching your asymptote. That's part of the graph. Now let's plug in 1. 1 over 1 is 1, and I have that point at 1, 1. That is another point that we're going to move with our transformation. So we have 1, 1, and -1, -1. When I plug in 2, I get 1/2, so I'm at the point 2 and then 1/2. And the same thing's going to happen. I plug in bigger and bigger numbers, and my points are going to get smaller and smaller. So I'm going to come down my asymptote, follow it, and curve around with double arrowheads. And so we get a graph that looks like that, and we call those 2 branches. So when I ask you to graph 4 points, it's 2 points on each branch. So here's a better graph of it. This is done in Desmos. You can see my point 1, 1 and my point -1, -1. We would have some arrowheads to show that it goes on forever. I have the green asymptote and the purple asymptote. This is our parent graph. I'm going to suggest to you that you draw your asymptotes in first. That will help you see where your shape of your graph is going to be, and then either use your transformations or make a table of values. So let's figure out what the letters do on the transformations. They're going to move the same way we've done all year long. So if A is greater than 1, it's going to stretch it. If it's less than 1 but bigger than 0, it's going to compress it, flatten it a little bit. The H, this is in with the parentheses, it's in with the X, so this is going to move it left or right, and it's going to go opposite of what we see. And then their plus K, that's going to move our Y up or down. And we have this. Also, if A is negative, that's going to be reflected over the X-axis. So let's try one. Here we have our graph of y equals 1 over x minus 2 plus 3. I want to think about how I could describe my transformations, and that's what I mean by the word move. So when I look in my denominator, I have x minus 2. So this is going to go to the right 2. Well, I would normally have an asymptote at x equals 0. So if I'm moving my whole graph to the right, my asymptote's going to move to the right. And I will have an asymptote at x equals 0. That's my vertical asymptote. Oops, sorry, 2. X equals 2. So I'm going to put that 2 in the middle of my table of values. I know that it's going to be undefined, but it's going to help me pick my values less than and greater than in just a minute. This plus 3 that's added on at the end means that my whole graph is going to move up 3. Well, I had a horizontal asymptote at 3, so when I move up 3, that means I have now a horizontal asymptote at y equals 3. So my asymptotes are x equals 2 and y equals 3. So let's come up with some values for our table, and then we'll compare it to our transformation. So if I know I can't be 2, I'm going to pick 2 values smaller. So 1 and 0 is good, and 2 values bigger, 3 and 4. So when I plug in 0, I think I'll just write here, I get 1 over negative 2 plus 3. So that's 3 minus a half, so that's 2.5. So I'm at 0 and 2.5. When I plug in 1, I'm going to get 1 over negative 1 plus 3, which is 2. So I'm at the point 1, 2. Now, the bottom sort of left branch started at negative 1, negative 1. If I check to see if I move the right way, I'm going to the right 2 and up 3. So I did move the correct spot, and then that's going to be one of my branches. Let's plug in the 3. So I have 1, and then 3 minus 2 is 1, plus 3. So this is 4. So I'm at the point 3, 4. And then when I plug in 4, I get 1 over 2 plus 3, which is 3.5. So I'm at 4, 3.5. If I check my original 1, 1, and I move over 2 to the right and up 3, I am correct. And we have that branch. Let's talk about the domain and range. Remember, the domain is x, and we can talk about what x is or x is not. In this case, I have the arrowhead, so x is going to be everything that way, x is going to be everything that way, except for 2. So we can say x is not equal to 2. And then with range, we're thinking up and down. So this arrow shows that we keep going down, this arrow shows that we keep going up, except for the 3. So our range is y is everything except for 3. Here's the final graph, just a little neater, but again, this point moved 2 and then 3, and then we're there. And then the other one started at 1, 1, and it moved 2 and 3, and we're there. Let's try this one. You can notice that my numerator is now 2. If I think about how it moves in my denominator with the x, it's x plus 1. It's going to go opposite. So this is going to go left 1, which means my asymptote is left 1. And that's my vertical asymptote at x equals negative 1. So I'm going to put negative 1 into my table, and that's my undefined. Then I have my sort of extra number at the end, minus 4, so this is going to go down 4. So 1, 2, 3, 4. You can see that I did not pick a very good graph window, but we're down there. And that's my horizontal asymptote at y equals negative 4. So we've done our transformation, we've drawn our asymptotes. I'm going to use the table of values to come up with my x values. Because my numerator there is 2, it's going to be a little more stretched. So picking numbers less than negative 1, we're going to go with negative 2, negative 3. Greater than negative 1 is 0 and 1. So when I plug in negative 3, I get 2 over negative 2 minus 4, which is negative 1 minus 4, which is negative 5. So negative 3, negative 5. And then when I plug in the negative 2, I get 2 over negative 1 minus 4, which is negative 2 minus 4, which is negative 6. So negative 2, negative 6 would be down there, and we've got that branch. I jump to the 0, so I have 2 over 1 minus 4 is a negative 2, 0, negative 2. And then 1 is 2 over 2 minus 4, which is negative 3. So 1, negative 3. And we have that graph there. My domain is x cannot be -1. My range, y cannot be -4. So your asymptotes help you figure out your domain. Your asymptotes help you figure out where your graph is. And that's the final graph there in Desmos. So to recap, we have our parent. We can use our transformations to move it left or right, up and down. Draw your asymptotes. I like to draw that first, and then plot 4 points with 2 on each branch. We did it. Nice job.